Welcome to The Explainer. Today, we're taking a pretty fascinating journey. We're going to start with a super messy, beloved family craft and end up deep in the heart of molecular chemistry. So let's dive right in.
Have you ever built a paper-mache volcano for a science fair? Or maybe you've helped a kid build one on a rainy weekend? You probably remember it, right? The crusty newspaper strips, that gooey flour paste everywhere, the pure anticipation. It's this shared nostalgia that perfectly lowers the barrier to entry for the hard science we're actually about to explore. Because, believe it or not, hidden inside that messy arts and crafts project is some truly elegant chemistry.
Okay, so before we get to the molecules, we actually have to build the thing. Let's talk about crafting the base.
According to the Blue-Eyed Mama blog, which is a fantastic resource for hands-on learning, by the way, you absolutely do not need a store-bought kit for this. You just start with everyday recycled stuff. Think a sturdy cardboard base, like an old pizza box, and an empty 2-liter soda bottle. You add some cardboard ribs to give it shape, slather on layers of newspaper mache, paint it to look like a rugged mountain, and finally, you make it erupt. Honestly, it's just a great chance to slow down, get your hands messy, and really engage with the physical world.
Now, in the papier-mâché world, there's actually a pretty great debate about the paste. You generally have two camps here. On one hand, a 1-to-1 white glue and water mix is going to give you the absolute strongest hold. But on the other hand, the unbaked flour method, which is just equal parts flour and water, is way quicker to whip up, and it's completely edible for any overly curious toddlers wandering around. Just a heads up though, if you go the flour route, make absolutely sure it dries completely, or you're going to end up growing mold.
All right, time for the main event. To create that iconic eruption, you just need incredibly simple stuff you probably already have in your kitchen. We're talking about 4 tablespoons of baking soda, a cup of white vinegar, a funnel, and maybe some optional red food dye just to give it that authentic lava look. You literally just dump the dry powder right into the belly of your volcano, pour in the liquid, and step back.
Well, we kind of lured you in with a fun craft, but now we're officially pivoting to the hard science. Let's meet the real star of the show.
So, what exactly is this basic white powder we so casually call baking soda? Formally, its name is sodium bicarbonate, or NaHCO3. It's a chemical salt, and it's composed of a sodium cation and a bicarbonate anion. And here's a pretty wild fact. It's actually naturally occurring. It's found almost exclusively as the minerals nacolite and trona. In fact, the absolute biggest deposits of this stuff are located in Wyoming, which means, yeah, we literally mine the star of our messy weekend project straight out of the earth. How cool is that?
Okay, let's zoom in a little closer and look at exactly what happens when those ingredients mix. Let's break down the eruption reaction.
Our whole volcano trick relies on something called an acid-base reaction. The basic sodium bicarbonate mixes with the acetic acid that's floating around in your white vinegar. When those two meet, boom, they spontaneously react to yield sodium acetate, water, and carbon dioxide gas. Now, you can contrast this with another reaction called thermal decomposition, where simply adding intense heat causes the sodium bicarbonate to break down all on its own. And actually, hold that thought on the heat, because we're going to explore that in just a minute.
But here is the absolute crucial point you need to understand. That dramatic, overflowing liquid, it isn't an explosion at all. Nope. It's literally just rapidly expanding carbon dioxide gas furiously trying to escape the mixture. The water and that red dye we added simply hitch a ride on those escaping gas bubbles, which creates that awesome foam spilling over the crater.
So that's what makes the toy work. But what happens when we take these concepts beyond the science fair?
It turns out the exact same chemical principles from our little toy volcano apply to some incredibly vital everyday tasks. We're going to look at 3 main applications here, just to showcase the pure versatility of this single compound. We're talking baking and cooking, fire extinguishing, and medical uses.
First up, let's talk about baking. Just like that escaping CO2 made our lava overflow, expanding CO2 gas actually acts as a leavening agent in your oven. When sodium bicarbonate reacts with an acidic ingredient in your batter, stuff like buttermilk, yogurt, or cream of tartar, it releases carbon dioxide. Those little bubbles get trapped inside the batter, which causes your cakes and breads to rise up, giving them that wonderful, characteristic, light and airy texture.
But consider this really surprising temperature threshold, 80 degrees Celsius, or about 176 degrees Fahrenheit. Remember that thermal decomposition equation we mentioned earlier? Well, this is the exact temperature where it kicks into high gear. If you heat baking soda, it releases CO2 all by itself, completely without any acid. But here's the catch. Without an acid present, the reaction leaves behind sodium carbonate, which gives baked goods this awful, bitter, soapy taste. And honestly, that is exactly why baking powder was invented. Baking powder actually contains the baking soda and the dry acid already mixed together in the exact right proportions.
Now, this exact same property builds right into a literal life-saving application, extinguishing fires. If you throw baking soda on a small grease or electrical fire, the intense heat triggers that thermal decomposition we just talked about. This is an endothermic reaction, which means it is quite literally absorbing heat away from the fire. Plus, that massive release of heavy CO2 gas starves the fire of oxygen, and it even creates a soapy foam that completely smothers the flames. That's precisely why sodium bicarbonate is the active ingredient in commercial dry chemical fire extinguishers.
And the applications really don't stop there. Medically speaking, it's a famous, fast-acting antacid. If you ever have acid indigestion or heartburn, it just means your stomach is producing an excess of hydrochloric acid. When you drink a safely diluted mixture of sodium bicarbonate, it spontaneously reacts with that extra stomach acid. It neutralizes it into completely harmless salt, water, and you guessed it, a little bit of CO2 gas. It's fast, effective relief born from the absolute exact same acid-base chemistry as our science fair project.
All of this brings us to the pretty deep industrial history of this everyday item, 1846. That is the year two American bakers, named John Dwight and Austin Church, established the very first U.S. factory to produce baking soda. Think about that. It has been an absolute staple for nearly 2 whole centuries, just seamlessly transitioning from massive factories to our kitchen cabinets and right into our medicine cabinets.
So, what does this all mean for us today? Let's talk about the lasting impact of this kind of hands-on learning.
I want to wrap up this explainer with a great quote from the Blue-Eyed Mama blog. She wrote, "Too many memories are wrapped up in that crusty paper mache to let it go just yet." Her family has literally kept their homemade volcano for over a decade. And honestly, that's really why this matters. We can sit around and read chemical formulas on a whiteboard all day long, but when we physically build something with our own hands and watch it furiously bubble over, that's when the knowledge truly sticks. It leaves you with a pretty fun question to ponder. What other incredible, complex scientific truths are hiding right there in plain sight in your kitchen cupboards, just waiting for a little water and vinegar to bring them to life?